Okay, if you are new to this video, please refer to Pharm Chem A. We have discussed already the anxiolytic and the other drugs in that part A. So now I'd like to continue the discussion from the barbituric acid, okay, which I have discussed in anti-epileptic class of part A. Now barbituric acid, if you see this, they are also containing uride structure, which I have mentioned already, and this uride structure enable them to produce an activity against epilepsy. Okay, now the structure I have drawn over here, that is R1 and R2, ethyl and phenyl, that is phenobarbital. Okay, this is phenobarbital. If you change the phenyl group to the this functional group 1, 2, 3, 4, 5, okay, so this become amobarbital, and if it is like this 1, 2, 3, the 5, okay, it become pentobarbital. Now if you change the uride ketone group into the sulfur, it become thiopental, okay, sodium. So this is one of the drug we have discussed with high volume of distribution, and they are having short duration of action, okay, in general anesthetics video. Now the next thing is the drugs, barbiturates, they are GABA A chloride channel agonist. They are also inhibitor of AMPA receptor. AMPA receptors are glutamate receptor, which I have already discussed in my earlier video. Okay, now the pH-pK relationship is very important to make them unionized at blood pH, and C5 substitution is very important. Now if you change the ethyl group to the CH double bond CH2, the single bond CH double bond CH2, and one more functional group is CH2 whole 3, CH3 and CH3. This become your secobarbital. Now these are the all classification in pharmacology we have mentioned in our video. Please refer to that. And if you change secobarbital, the ketone group again in sulfur, it become thiamylal, okay. And one more drug is methohexital. For methohexital, the structure is little different. The methohexital include the R1 is the same as CH2, CH double bond CH2, the first functional group. Then second was the CH, CH3, C triple bond C, CH3. Okay, so this is the second substitution, including N1 CH3. That's your methohexital. So it is also like thiopental kind of the action. Now the synthesis I have told you, it is often starts with your diethyl malonate and urea. Okay, this is a urea structure, this is diethyl malonate structure. Now the metabolism often follow the omega -1 oxidation, okay, because it is long chain, and you have the other sedative drugs like etomidate, propofol. You can find it on the structure. I have mentioned only also in our general anesthetics video. Etomidate, propofol, then ketamine. Okay. So apart from that, you have methaqualone. Okay. Now this is a quinazolinone derivative. Now if you remove one nitrogen and one ketone group, okay, from this particular structure, this drug is known as a prodrug of it's a kind of prodrug. It's not a prodrug. It is glutethimide. Okay, so now you have one more drug which is prodrug known as primidone. Okay, primidone. So these are the drugs GPAT can ask. Okay. Then you have some paraldehyde, chloral hydrate, 8th chlorovinol kind of drugs, a very obsolete old drug. They will not be asking these things. Okay. In case, so I have just told you. Okay. Now after that you come to the antidepressant. Antidepressant class, the first pharmacophore of antidepressant over here is mentioned as tricyclic antidepressant. Okay, tricyclic antidepressant. This is made up of the 3 cyclic structure. Okay, first drugs over here, it is known as your imipramine. Okay. Now if you remove this one methyl group, it becomes desipramine. Now the imipramine also used for nocturnal bedwetting of children. It's also used for panic and anxiety. Now if you add chlorine group over here, it's become chlorimipramine. Okay. Now SAR, the 7-member ring, should be separated from the nitrogen with a propylene bridge. Okay, this is a vital SAR point. And desipramine is non-NRI. It is non-adrenaline reuptake inhibitors along with antihistaminic and alpha-1 antagonistic activity properties. Okay. Now if you change the structure of imipramine with the cycloheptane with a double bond, this is known as ylide. Okay. So if you see the 10-11 dihydro group, okay, and this is a 5-ylidine. 5-ylidine is the basic structure of the drug known as amitriptyline. Amitriptyline. Now if you add a oxygen over here, okay, like this, it's become doxypine, which is oxocongener of amitriptyline. Okay, if you remove one methyl group, it becomes nortriptyline, no methyl amitriptyline. Nortriptyline, it is used to treat for ADHD, smoking cessation, and neuropathic pain. Okay, then after that you have the next antidepressant drug, which is known as your SSRI, selective serotonin reuptake inhibitors. You have fluoxetine, okay, fluoxetine. Then you have the paroxetine.